All right, today we're going to talk about finding number of moles, number of grams, and number of molecules in a compound as opposed to just an element, which is what we did in the previous video. So we're going to start with a compound called calcium sulfate, CaSO4. And you'll recall from our prior studies of this that in this molecule you're going to have one atom of calcium, one atom of sulfur, and 4 atoms of oxygen. So all we need to do is to look at the periodic table and add all of those different atoms together to find the molar mass for calcium sulfate. I am going to write it out for the first couple that we do so you can see exactly what I'm doing. You do not have to do this every time you find a molar mass of a compound. It would end up being an awful lot of writing. So again, I'll do it for the first couple, and then once you understand it and once you know what you're doing, you don't have to write it out to find the molar mass of these, okay? So for calcium sulfate, I have one molecule of calcium, which is 40.08 grams. I have one molecule of sulfur, which is 32.06 grams. And again, this is coming from the periodic table. So if you look at the periodic table, you'll see this 40.08, the 32.06. You'll find that on the periodic table. And then I have 4 molecules of oxygen, and they are 16 apiece. And so since you have a scientific calculator, it will obey order of operations. Now, you don't have to put in these parentheses when you type it in. You could just type in a multiplication. So when you type it in, you're going to type in 1 times 40.08 plus 1 times 32.06 plus 4 times 16. Obviously, you wouldn't even have to type in the 1 times because that's not going to make a difference anyway. And so when you do that, if you type it in just like that, the calculator will do all of the multiplication problems before it does the addition because it will follow order of operations. So when you get done, you should have an answer of 136.14, and the correct units on that is grams per mole, because for every 1 mole of calcium sulfate, there will be 136.14 grams, okay? I would encourage you to get your calculator, type it in, make sure you get this same answer. We'll do one more example. We're going to do barium carbonate, which is BaCO3. That's what it's called, it's barium carbonate. So again, I have one barium, which is 137.33. I have one carbon, which is 12.01. And then I have 3 oxygens, which are 16 apiece. And so if you type in 137.33 plus 12.01 plus 3 times 16, then you will end up with 197.34 grams per mole, which is called the molar mass of barium carbonate. Okay, so like I already said once before, you don't have to write that out every single time. I wrote it out the first couple times so you could see for sure exactly what I was doing. All right, now we're going to use these molar masses that we have just calculated, and we're going to do some other conversions with them. So if you look at the third problem down on your sheet for today, we're starting out with 0.36 moles of calcium sulfate. And just like the problems I worked yesterday, you're always going to take what they give you and you're going to put it over 1. Cardinal rule of always solving these problems correctly, okay? Now, the problem is asking me to convert that to grams. I don't know how many grams that's going to be. So what I need to do is I need to say, well, I need to get rid of moles of calcium sulfate on the bottom. I need to change that to grams of calcium sulfate, which is what I'll put on the top. Because I've already calculated the molar mass, I know that for every 1 mole of calcium sulfate, I have 136.14 grams of calcium sulfate. So moles will cancel out, and when you multiply those two together, you should end up with 49 grams of calcium sulfate. Okay, two significant figures here because I started out with 2 here. All right, we'll do one more. How many grams are in 7.26 times 10 to the 23rd molecules of barium carbonate? Again, we've already calculated the molar mass of barium carbonate, so I'm going to take what they gave me and I'm going to put it over 1. So I'll have 7.26 times 10 to the 23rd molecules of barium carbonate, and that goes over 1. Okay. Now again, in your book, this is going to be an example of a problem where he does a 2-step calculation, and I tend to just string it all into one. Whichever one is easiest for you is fine with me. It doesn't make any difference. And just be aware that the answer in the solutions guide may be a little bit different in the final couple of decimal places. Okay, so I need to go from molecules of barium carbonate, and the conversion factor you're always going to switch is molecules to moles. So I'm going to put moles of barium carbonate on the top. In 1 mole, you always have 6.02 times 10 to the 23rd molecules. Okay, that never changes. And then, because this will cancel out, because I'm trying to find grams, my next conversion factor is going to be molar mass. So I will have moles of barium carbonate, because that's what I need to get rid of. And I'll have grams of barium carbonate up here at the top. I know that when I calculated it up here, for every 1 mole, I had 197.34 grams of barium carbonate. So the moles will cancel out, and I'm left with the number of grams. So when you do this, make sure that you remember that if the number's on the bottom, you need to divide by that, not multiply. So when you type it into your calculator, it's going to be 7.26 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times 197.34. And that should give you an answer of 238, 3 significant figures, grams of barium carbonate. Okay? So your problems for today are going to include examples just like these where you're using compounds and you need to calculate the molar mass of the compound in order to then make the conversions that you need to be able to make. Again, always take what they give you, put it over 1, and then set up your conversion factors from there.